So far in this lesson we've been talking about a binomial times a binomial, but if you notice that these two examples, I don't have a binomial times a binomial anymore. Now I have a binomial times a trinomial in part A, and I've got a trinomial times a trinomial in part B of example 4. So what we talked about so far, you can only use FOIL when? When can you use FOIL? When you have a binomial times a binomial. Notice, I don't have a binomial times a binomial, so I am not going to be able to use FOIL. But luckily, there's something we've done before that will actually make this a little bit easier. We are going to end up distributing each part of my binomial to each part of the trinomial. A way you can kind of think about this is you've got to basically multiply the first part of the binomial times everything, second part of the binomial times anything. And if you really wanted to get into the math of why this works, you could rewrite this as 6x times 2x squared minus 3x minus 5 plus 5 times 2x squared minus 3x minus 5. And then you could distribute each of these and then combine your like terms. Now, I don't know about you, but I don't like to have to rewrite all this right off the bat. And actually, you'll see where we get this from when we start talking about factoring a little bit later. But for now, if you want to write it this way, by all means, go ahead. But I'm not going to expect you to do that. All I want you to show is that I got to distribute each part to my trinomial. And by saying that, I mean I've got to take 6x and distribute it to each of these things inside the parentheses, and then I'm also going to have to take my 5 and distribute it to each of the pieces inside the parentheses. And actually, this is what you're doing when you FOIL something with two binomials. It's just easier to think about it as FOIL. Okay? So you just distribute each part of the binomial, or the first part, to each piece in the second part. And then just to make sure I have room, I'm going to erase this part over here on the right. But again, if you want to write it that way, feel free. So now, when I actually go through and do this, 6x times 2x squared is going to give me 12x to the third power, because remember, this is 6x to the first. X to the first times x to the second, you add exponents. Then I get 6x times negative 3x. That's going to give me negative 18x squared. Then I have positive 6x times negative 5 gives me negative 30x. I just multiplied 6x by each part of the trinomial, or the second piece. You don't need to worry about binomial, trinomial so much. Just the first term in the first piece, okay, breaking it down into very simple language. First part of the first piece multiplied by each part of the second piece. Then I got to take the second part of my first piece and multiply it by each part of my second piece. Okay, so positive 5 times positive 2x squared gives me positive 10x squared. Positive 5 times negative 3x will give me negative 15x. Positive 5 times negative 5 gives me negative 25. And now I've got everything multiplied out. The last thing to do will be combine like terms. If you notice, I have a negative 18x squared, a positive 10x squared, and I also have a negative 30x and a minus 15x. So I do have some terms that I could combine here. There's no x cubed terms besides the first one, so that's going to stay 12x cubed, minus 18x squared plus 10x squared. Negative 18 plus 10 gives me negative 8x squared. Negative 30x minus 15x. Negative 30 minus 15 gives me negative 45x. And then I just have my minus 25 at the end. So it's not that different than what we're doing earlier using FOIL. It's just now we don't have that rule where it's first times first outside, inside times inside, last times last. But we know we just have to distribute each part of my first piece times each part of my second piece. And we're going to take that exact same idea when we go to part B, except now I've got 3 pieces, or 3 parts in my first piece, so I'm going to have to distribute 3 different times. So I've got 2y squared needs to be multiplied by everything. Then I'm going to have to multiply my 3y times everything, and I'll try to make so these arrows don't all run together. And then I'm going to have to take my -1 and multiply it by everything. And I know there's some of you that are thinking, oh my word, this is so much work, it's so hard. It is not terribly hard if you break it down step by step. It is a longer problem, but do not let the fact that it's a longer problem intimidate you. You can still do it. So I'm going to go ahead and I'm going to get started. 2y squared times 3y squared gives me 6y to the 4th. Remember, when you multiply, you add exponents. Then I've got 2y squared times -5y. That will give me -10y cubed. Then positive 2y squared times positive 2 gives me positive 4y squared. Now I go to my next piece. 3y times 3y squared gives me positive 9y squared. 3y times -5y gives me -15y. 3y times positive 2 gives me plus 6y. And then I go ahead and do my last one. -1 times 3y squared, -3y squared. -1 times -5y. Notice, negative times a negative gives me positive 5y. And then -1 times positive 2 gives me -2. And here we're actually going to have more like terms than we've had before. So notice, and actually looking at this I made a mistake. If you look at my green terms, this should be 9y cubed, because we had 3y times 3y squared, and this second term should be 15y squared. So make sure you go back and correct that. You should have plus 9y cubed minus 15y squared. Okay, in case you didn't catch that while I was doing that, I forgot about this y when I was multiplying. So now I'm going to look at my like terms. I can see I only have 1y to the 4th, but notice I've got minus 10y cubed plus 9y cubed, so there's a set of like terms. And then I've got plus 4y squared minus 15y squared minus 13y squared. Then I've also got a positive 6y and a positive 5y. So I've got a few different like terms that I can combine. And I'm just going to go ahead and do that right now. I start out 6y to the 4th. Remember, we always want to write these in standard form, so highest exponent comes first. Now I've got negative 10y cubed plus 9y cubed. Negative 10 plus 9 gives me negative 1y cubed. And remember, you don't have to write this 1 here. Negative y cubed is the same thing as negative 1y cubed. I'm just writing the 1 in case you're confused about what the coefficient should be or the number in front of the variable. Now I'm going to combine my squared terms. I have positive 4y squared minus 15y squared minus 3y squared. If you think about 4 minus 15 is negative 11 minus 3 gives me negative 14y squared. Then I got to combine my y terms. Positive 6y plus 5y gives me positive 11y. And then don't forget about your negative 2 at the end. And there's your answer. A lot of steps. Steps aren't terribly difficult, and you might think it's weird I'm saying that, since I did make a mistake right there, but that was just a silly mistake for me not paying attention. And then combining like terms, you guys know how to combine like terms. So this is all stuff you know how to do, it's just we're putting it in a situation where you have to do a lot of it all at once. Good news is, that's all there is for this lesson. Go ahead and let me know if you have any questions.